Hey guys, welcome back. We are now doing problems 4, 5, and 6, which we're going to call find the angles. Find the values of the angles once we know where things are at. This actually isn't going to be too terribly bad for each of the different things. So what we want to do for something like this is that when they give you a value, they say, here's the point. It's on the terminal side of the angle. Let's figure out what we're going to do. Moving some stuff out of my way so you guys can see it. First thing you want to do is graph that. So -6, -2. Boop, boop. That is in our third quadrant. So we'll go -6, -2. That puts us right there. Now, that is the terminal side of the angle. So we're looking at an angle right here, which is great and important for us to think about. However, what we have to remember is that when we're looking at these, and by the way, I do not believe this little squared thing that's up there is supposed to be there. It's just supposed to be cosecant, but apparently they got stuck in. So I'm sorry about that. What we're really doing is just trying to find the values of this triangle, knowing that these are negative, so that we can say, here is what we're going to use with cosine, sine, secant, cosecant, and tangent. Why there is no cotangent, I think, is probably because I'm an idiot and I screwed up putting this on. So again, sorry about my idiocy. I'll try to do better next time. Here we go. Let's find out what the hypotenuse of this is. So we'll do -6 squared plus -2 squared is going to equal R. Excuse me, we'll call it C squared. So 36 plus 4 equals C squared. 40 equals C squared. And if I take the square root of both of those, I'm going to get 2 root 10 is equal to C, or 2 root 10 is my hypotenuse. Now, we have to remember with this is that when we are doing all of the sides of this is our Y value, this is our X value, excuse me, our X value, and this is our hypotenuse. Now, why did I figure out the hypotenuse in the first place? I guess I just get stuck on this stuff. I guess I didn't need to even think about that. Since everything is going to be some combination of X's and Y's, now you know how to find the hypotenuse. There we go, guys. All right, so what we have to remember is that the sine of theta is going to equal the Y value, which, guys, I don't know if you know this, but the sine of this value is going to be, well, no, we do have to do this. That's why, because it's not a unit circle, and because I'm tired and you didn't understand that that was the case, but now you're watching this video, so it's great. It's because when we're doing something like this, we're going to have to use this with the SOHCAHTOA stuff. So if I'm going to be doing this, it's not the unit circle because this isn't 1. The only reason that the sine is equal to the y is because it's opposite over hypotenuse, and the hypotenuse is always 1 in the unit circle. So right now, the sine of this is going to be -2 over 2 root 10. Well, here's what I'm going to do. Those will cancel. If I multiply by root 10 for both, I'm going to get negative root 10 over 10. That is my sine. My cosine is going to be -6 over 2 root 10. These will go away, and that's going to become a 3. And this is going to now be -3 root 10 over 10. That is the sine and the cosine of these things. Okay, now tangent. Tangent's actually really pretty easy. Tangent of theta is going to equal opposite over adjacent. So -2 over -6, or 1/3. Totally awesome. Now cotangent is just the reciprocal of that. So it's going to be 3 over 1, or 3. The secant is the reciprocal of that, which makes me want to freaking die. So let's do it the other way. Let's go instead of in this case, it is adjacent over hypotenuse. This would be hypotenuse over adjacent. Hypotenuse is 2 root 10. Adjacent is -6. That is a whole lot easier to deal with without me having to think about all the crap of doing this again. So this is going to be root 10 over -3. And if I'm going to do the cosecant of theta, that is going to be, well, hypotenuse is 2 root 10. Opposite is -2. So this will actually be negative square root of 10 as the cosecant. I don't know why I keep writing 2. Perhaps because it's the end of the day and I've already taught most of my classes, and I'm just doing this video for you because you will ask for it and need it. Okay, so that is our problem number 4. That is all of our values. Now, 5 and 6 will do almost exactly the same thing. However, they're giving to you in a little bit of a different way. So here's what we're going to do. I want all of the values of the remaining trig functions. In this case, we have been given that the cosine is -3 over 5. All right. And we're giving that the sine is greater than 0. So let's deal with the quadrant first. In this case, the quadrant we're going to be looking at. Cosine is negative. That's our x is negative. The sine is positive. So we're dealing with a problem that is going to give us a value where our triangle will be right there. Now, if the cosine is -3/5, what I'm going to do is to remember that when we look at this right here is our adjacent, and this right here is our hypotenuse. Hypotenuse is never negative. So this means the -3 will be this one, and the hypotenuse is going to be 5. Now, guys, I'm not stretching you too far to say this is a 3, 4, 5 triangle. It is in the proper quadrant. And so right now, to do the rest of them should not be very difficult because these are all whole numbers. So we've got the cosine. The sine of theta is going to equal 4/5. The tangent of theta is going to equal 4/3. The cotangent of theta is going to equal -3/4. The cosecant of theta is going to equal 5/4. And the secant of theta is going to equal -5/3. So again, reciprocals of each other, and this is the reciprocal of the cosine. Okay? That is how we do it based on the triangle. One last problem for this one. And then I'm probably not going to make another video today because I got kind of too much to do. So I'll keep working at it. We'll see if I can get through the rest of them over the course of the next couple of days and post them up. All right. Same general idea. It is telling us that our sign is negative. So in the case of this, that is putting us in these two quadrants, in the third of the fourth. It does, however, say that the tangent is also negative because it's less than 0, which means negative y, positive x. We are looking at a triangle here. Okay, so if the sine is -2/3, I'm going to say, so that is opposite hypotenuse. Hypotenuse is going to be our 3. Opposite is going to be our -2. This doesn't have one of those nice ones, so we're going to have to use the Pythagorean theorem to find it. Not that big of a deal. So this will be to find our adjacent one here. And so we're going to do -2² plus a squared is equal to 3 squared. 4 plus a squared is equal to 9. A squared is equal to 5. So a is equal to the square root of 5. That's what we have for our x value here. So now I've got the sine. I've got my triangle. So the cosine of theta is going to equal square root of 5/3. The tangent of theta is going to equal -2 over the square root of 5, which means if I rationalize it, will be -2 root 5/5. I know you could see the steps there, but I wanted to kind of get through them. And so then the cotangent of theta is going to be square root of 5 over -2, which is fine. The negative go out front if you wanted to. Well, let's do this here. If I'm going to do the, sorry, I'm looking at what I have right here, and my brain just stopped mid-thought. If I want to do the cosecant of theta, it is the hypotenuse over the opposite, so that will be 3 over -2. And if I want to do the secant of theta, it is going to be, in this case, the hypotenuse 3 over the adjacent, which is square root of 5, and I will have to rationalize that. So this will be 3 root 5/5 for this one. And that gives us all of our values for these. And we have now done 4, 5, and 6, which is great. We're going to do 7 and 8 for our next one for applications, but that is not what we are doing today. So guys, good job.